Okay, so today we're doing solving logarithmic equations. So until now, when we solved a logarithmic equation, they've always just had one log. So you could have had this where you have log x6 equals 7. And if you don't know the base of the log or you don't know what's beside the log, I told you to convert to exponential, correct? When you had one log. So we could go x to the 7 equals 6. And then we'd raise this to the 7th. And we'd have x equals 6 to the 7th. Or the 7th root of 6. And that's what we did before. So whenever we had one log, we could always get it to be exponential. So I also did an example where it was 2 log 6 x plus 2 equaled 8. What would you have to do before you could convert it? Either bring the 2 up as an exponent or divide both sides by 2. But we have to have a 1 in front of the log before we can convert it to exponential. So then we have it in that form, and then we can do what? Convert to exponential. So we can go 6 to the 4 equals x plus 2. And then we could subtract 2 from both sides. And we get 6 to the 4 minus 2, which is a number. $12.94. And we still have to check these values. So when I look back, I can check this. I can plug it into here. So I get 1296, and then I go 6 to the what is 1296, which is actually 8. So we're right. I could check this by plugging it back in here. But what I need to know is this number down here can never be 0 or negative, and whatever's beside my log can neither be 0 nor negative. If it is, like if when I plug my x back in, I get a negative or I get a 0, that root would actually be extraneous. It wouldn't actually exist. You can find it, but it doesn't work. Okay, so let's look at cases where all we've done so far is there's been one log. What happens though if we have more than one log? So this is example 1. Solve. Log 9x plus log base 9 of 3 equals 1. What do we do? We can't convert to exponential right now because what? How many logs are there? 2. And then we convert to exponential, we have to have a 1 in front of the log, and there can only be 1. So they're both base 9 though, so what could I do? Multiply them. Put them together by the multiplication rule. So I can go log base 9. Oops. Of x times 3 equals 1. And then I have log base 9 of 3x equals 1. And then what could I do? Just like the previous questions we had. I have one log. It has a 1 in front. What can I do now? Convert to exponential. So the base of my log becomes the base of my exponent. What's not with it becomes my exponent. And it equals 3x. Divide by 3. And x equals 3. Now we can check it. I know immediately that it's actually possible because when I plug the 3 back in for x, there's not a negative beside my log, right? Like if I typed into my question, my calculator, if I typed in log of -3, your calculator would be like, no, not doing this. Not happening. I wish it talked to you in like real world, like people ways, like, no, not going to happen, not today, or something like that. Wouldn't it be fun? Rather than just error. You're like, oh. Okay. So when I plug it back in, though, I will get log 9 to the 9, which is 1. So I get 1 equals 1. And I check it, and it's good. Okay? So you can check every single one of these answers. How else could you check it by rather than just plugging it back in? Anyone know? How could you check it? This thing is really expensive in front of your face. Yeah, so you could plug it back into your screen and see if it works. But what else could you do? You have an equation. Yes, you have an equation with one variable. Could the variable happen a few times? Yes, but it just has to be one variable, like an x a few times. If it's an x and an m or something, you'd be done. You couldn't do this. One variable with an equal sign, you could y1, y2, find out where they intersect, and it should be the same answer. Okay. You guys try this one out. See if you can do it. I'm not going to give you any hints. I just want to see if you can do it. Solve. Quiet, please. Log base 5 x plus 1 plus log base 5 x minus 3 equals 1. All right, so we're going to get log 5. They both have 1s in front, positive 1s, so they get multiplied. X plus 1, x minus 3 equals 1. 5 to the 1 equals that. Five equals x squared minus 2x minus 3. Then since it's a quadratic, move everything to one side. Always. X squared minus 2x minus 8. But multiplies give me -8 and adds give me -2. X minus 4, x plus 2. And when I solve those out, I get x equals 4 and x equals -2. When I check it, though, 4 will work. 4 plus 1, 5. 4 minus 3, 1. When I check them, that one's good. -2, however, I get -2 plus 1, and I get what beside the log? A -1. Is my calculator even going to let me type that in? Well, it'll let me type it, but it's going to tell me no thanks, no dice. And so this one is extraneous. When I plug this back in for x, I get -2 plus 1, and I get a -1 beside a log. And my calculator did not like that. Neither does yours, actually. Okay. Let's try this one. What if I give you this? So both of the ones that we just did had logs and a number, correct? Got the logs together, equal to the number, converted to exponential. What happens if they're all logs, though? So I get log base 3x plus log base 3x minus 1 equals log base 3 of 6. So what I could do is I could move all the logs to one side, set it equal to 0, get them together, and then exponential. But there's also a faster way, actually. When they're all logs, it's way easier. Put the logs together on the left. So we get log base 3, and we can put these together because they both have plus 1s in front. So log base 3 of x times x minus 1, and it equals log base 3 of 6. Knowing what we know, what could we say then? And why would this be easier? Log base 3 of x minus 1 equals log base 3 of 6. Yeah. Absolutely. If this is log base 3 of this equals log base 3 of this, then these two must equal. And you don't have to do converting to exponential at all. So actually, when they're all logs, it's even easier. These are the ones I don't get anyone answering, but they're actually way easier than when you have a number. So we have x times x minus 1 equals 6. X squared minus x minus 6 equals 0. But multiplies give me negative 6 and adds give me negative 1. X minus 3, x plus 2. So I'm going to get x equals 3 and x equals negative 2. Now, in our examples, the negatives have not worked, but you have to check them back because sometimes in some of the equations, it'll be minus a minus something, and the negative actually ends up working because it makes it plus. When you put the positive in, you get a negative. So you actually can't just say, hey, it's a negative, it's extraneous. You need to look back and see, does it give me a negative beside the log? So I take this 3 and I plug it back in. I get a 3 here. That's fine. I get a 3 minus 1 here, which is 2. So that's okay. I take the negative 2, I plug it in. I get a negative 2 beside the log. Is that okay? No. So it's extraneous. Does that mean that now, because 2 of them were negative and those were extraneous, that it will forever be the negatives that are extraneous? No. Okay? You have to check them. Okay, here's the big one we're going to go through. Example 4. Everyone that we've dealt with so far has had 1s in front of the logs, right? Toss some papers. So what happens if I ask you to solve 2 log base 3x minus log base 3 x plus 3 minus 3 equals 0? So anything that doesn't have a log on it needs to go the other side, correct? And in order to put logs together, what do I need to have in front of the log? 1s or negative 1s. So I'm going to add the 3 over, and I'm going to bring the 2 up. With a negative 1 in between, what do we actually do then? Divide. So we get log base 3 x squared over x plus 3 equals 3. And now what do I have to do? I don't just have all logs, so I can't say this equals this. What do I have to do when I have one log? Exponential form. So I'm going to get 3 to the 3 equals x squared over x plus 3, which is actually 27 equals x squared over x plus 3. What do we do in this instance? Is 27 a fraction? Can 27 be a fraction? Any number can be a fraction. What could we write it over? 1. When we have a fraction equaling a fraction, what can we do? Usually this brings joy to people's hearts everywhere. Fraction equals a fraction. Nope. That's when you add or subtract fraction. Thank you. Yes, cross multiply. That's all we're going to do. There are some crazy options. I'm going to choose cross multiplying. So when you have a fraction equals a fraction, you can cross multiply. 1x squared equals 27 times x plus 3. Then you distribute. And then you get x squared minus 27x minus 81 equals 0. And the catch with this is you can't factor it. So if you can't factor it, there's no answers? No, that is not the case at all. If you can't factor it, you have to use the quadratic formula. Yes, I totally agree. So this is A, B, C. Remember, you don't have to memorize your quadratic formula because it's in the top left of your formula sheet, and it tells you what form it has to be in. Ax squared plus bx plus c. So you're going to get x equals negative a negative 27, so plus 27, plus or minus negative 27 squared minus 4 times 1 times negative 81, all over 2 times 1. Which gets you 1,053 under the square root. And then that can break down into 81 and 13. The 81 comes out and it's a 9. So if I can take a 9 out of 27 and 9, do I do that? No. You would just have a GCF sitting out front. The only time you take it out is if you can take it out here, here, and the bottom. Now to check for extraneous, we need to turn it to decimals. So we're going to get the top one, which is negative 27 plus 9 root 13 divided by 2, and you get 29.72. And then x equals 27 minus 9 root 13 divided by 2, which is negative 2.72. A quick way to check this would be with your calculator, correct? How can we check it with our calculator? We have to type the original in. So not this little green 2. We type this into my y1, and my y2 is the x-axis. So go ahead and do that. Make sure your x window at least is from negative 3 to 30. Why does my x min and my x max have to be from negative 3 to 30? Because those are my answers. So I want to see if those answers actually exist, right? So I'm going to type the original in, y1, y2. Oops, here it is. And then I'm going to look at my graph. And when you look at your graph, this one crosses the x-axis at 29.72. But the graph actually is completely all on the positive side of the y-axis. So it's never going to cross at negative. This one's extraneous.